This is going to be a video about half equations, which can cause quite a few problems. So let's have a look at this reaction between sodium chromate and silver nitrate to form sodium nitrate and silver chromate. We could break that standard reaction down into an ionic equation. That means just pulling apart each species. So Na there is going to be Na plus. We know that chromate is going to be 2 minus because we've got balanced charges there, 2 plus, 2 minus. Silver, nitrate, and all of these are in aqueous solution. But then we get a precipitate formed, and that's a solid, okay? And we've got silver chromate there and sodium nitrate also in aqueous solution. Now the first thing that we're going to have to understand about this is that we've got spectator ions. Now the spectator ions are going to be ones that do not change their state from aqueous to solid. So sodium, it's aqueous there. On the right hand side of the equation, nitrate is aqueous on the left, as is nitrate aqueous on the right. So they're not changing their state. Sodium there, that's also aqueous on the left, aqueous on the right, no change of state. So we can basically drop those from the equation and then look what's left. We've got chromate aqueous, but on the right it's a solid. We've got silver aqueous, but on the right it's a solid. So those are the ones we're going to be interested in. So the spectator ions are called spectator ions because they remain in aqueous solution. They have not changed their charge and they have not changed their state from the left reactant side to the right side, the product side. So that's the first thing to understand. Okay, so let's think about that full equation and think how we could split that into a half equation. So let's look at chromate in aqueous solution there goes to chromate in solid solution there. That's going to be one half equation. And then silver in aqueous solution there is going to go to silver as a solid there. And that's going to be another half equation. So if we pull the chromate down to here, we are effectively seeing CrO4 2 minus going to CrO4 solid. Okay, we can form a second half equation, take the silver aqueous there going to silver solid. Now, what we need to add to this is the electrons. I'm going to suggest the first step that might help you with this, because students can struggle with this, I find, is we're going to draw out a number line here, like so. First up is put the CrO4 2 minus on the number line at -2, because that's the charge that it has. And then we're going to put the CrO4 solid at 0, because that molecule is not charged. So if we see a molecule without a charge on, we can always just put it there under 0. So now we need to think, how can we go from CrO4 2 minus to CrO4? Now we've got electrons and they're always negatively charged. So we can either add or take away negative charge. Here we need to think about our mass. If we're on -2 on a number line, and we wanted to take it to 0, we want to go in the positive direction. So how would we go in the positive direction? Well, you would think you'd add, but actually you're going to have to minus a minus. And the reason you're going to have to minus a minus is because we know in maths, as we minus a minus, we're going to get a plus. Okay, so we're going to minus 2e minus, and that will take us to 0. Is what we have to put in the half equation. is 2e minus. What about the silver? Well, let's put Ag plus on the number line. It's at plus 1. And then it's going to end up as solid naught. So how are we going to go on the number line? We need to go in the negative direction. So if we want to go in the negative direction from silver plus 1 to silver 0, we now need to add a negative charge. So we're going to add 1 negative charge there. Now, in this situation, you'll see the two half equations, we can put them together, and we normally leave the electrons out. Looking at the bottom line there with the silver and the top line, they are not balanced in terms of electrons. So we can balance them in terms of electrons by doubling everything up in the silver. The electrons are now balanced and we can cross through them, and then that leads to, if we put those two equations together, we get the equation at the top there. Okay, let's look at another example. Let's look at chlorine Cl2 going to Cl minus. There's something else we've got to consider here, so I want to go through this one. So first of all, in the same way, we can put the Cl at 0. It doesn't have a charge on it, so that belongs at 0 on the number line. We can put the Cl minuses at -1. And then we can think, well, where are the electrons going to go? Are they going to be added or taken? Well, we need to add a negative charge there to go from 0 to -1. However, there's one thing we've forgotten to do there, and that is, as well as the electrons adding up, we've got to balance the molecules here. And when you look at this one, we've got Cl2 on this side, but only Cl on there. So we have to balance the atoms. We've got 2 atoms there, but only 1 atom are there. So how are we going to do that? We're going to put a 2 in front of the Cl minus. And that means we're actually going to have to add 2 electrons to take that down the number line. The way I suggest you go about it is as follows. 1, balance your molecules. For example, if you've got Cl2, on one side it's got to be 2Cl on the other side. Secondly, put your ions and molecules or atoms onto a number line. Remember, if the molecule has no charge, put it at 0. It's only going to be +1, +2, +3, or -1, -2, -3. Put it on the number line. That's the second step. The third step, think, do I want to drive it to a more negative number? If I want to do that, move it in that direction, I need to add electrons. Or do I want to drive it in the direction of a more positive number? And I'm going to minus a minus. Okay, I'm going to take away some electrons, and that's that.